In this lecture, we are going to discuss about the motion of blocks in contact. Now, we consider there are three blocks A, B, C. They are in contact with each other, and the three blocks are kept on the smooth frictionless surface. And a force F is acting from left to right. Therefore, all the three blocks are moving towards right with an acceleration A. Now, let us consider the free body diagram for each mass. So, first you consider the block A. And the block A, so this is your block A. And the block A is having mass m1, and the force is F. Capital F is the force acting on the block of mass m1, and it is moving with an acceleration A. Now, this small f1, f1 is called as the contact force. This contact force is acting on the block A from B. So, since the block B is in contact with A contact force is acting on A due to the block B. Now, if you consider a block B, so this is a block B, mass m2, here two forces are acting. One force is F1 is a contact force. This is a contact force acting on the block B due to A, and since B is also in contact with the block A, there is a contact force F2 is acting on the block B from right to left. So F1 and F2 are the two contact forces. Contact forces they are always acting towards the body. F1 is acting towards the body B, F2 is acting towards the body, so there are two contact forces F1, F2, and the block is B is moving with an acceleration. On the third block, if you consider a block C, here the mass is m3, it is moving with an acceleration A. There is only one block for only one contact force is there, because the block B and C, they are in contact with each other. So the F2 is the contact force acting from B to C. You know that suppose you consider two blocks A and B. If you look at the extreme right end, and there are two blocks are kept here. So now here there are two. So this is the surface. This is the surface of contact. So one force is acting. There is a contact force acting to the block A from B. Another force is acting. That is again a contact force is acting on B from A. So these two forces are equal. So along the surface, the contact force acting from B to A as well as A to B, both are equal. So that must be, you must keep in mind. Now, if you consider the first block, now let us write down the equation of motion. Now here, capital F is the external force acting on the block, and F1 is the contact force. Since the body is moving towards the direction of the force, so F must be larger than F1. So F minus F1 is equal to m1A. So this is your equation 1. Now, if you consider the block B, there are F1 and F2. They are two contact forces acting on the body. Since the body is moving along the acceleration is along the direction of the force from left to right, F1 must be larger than F2. So F1 minus F2 is equal to the m2 times A. So this is Newton's law. According to Newton's second law, we are writing the equation 1 and 2. Similarly, if you consider the third block, this is the mass block of mass C, the mass m3. The block is the C having mass m3. and contact force F2 is acting from B to C, and acceleration is again along the direction of the capital force, the external force here. So here on the F2, because only one force is acting on this block, F2 is equal to M3. So you have three equations, equation 1 and 2 and 3. Adding 1 and 2 and 3, you will get the total force, because this minus F1, F1 cancels, minus F2 and this plus F2, this gets cancels. Once if we add, finally you will have only the capital F. Capital F is equal to, adding on the right side of the three equations, M1 plus M2 plus M3 into A. Therefore, the acceleration can be determined by F, the external force that you are applying, divided by the total mass, M1 plus M2 plus. So this is the expression for the acceleration. Now if you substitute this value of acceleration in equation 3, so if you substitute A in equation 3, F2 is equal to M3 times A, and A is equal to F divided by M1 plus M2 plus M3. Therefore, you will get this expression for F2. Now if you substitute F2 back to equation 1, F1 is equal to M1 plus M2 M3 into A, and since the acceleration is already derived, you substitute the value of the acceleration, that is equal to M2 plus M3 into F divided by M1 plus M2. So you can get the contact force. So the contact force between the block A and B is determined. The contact force between B and C, which is F2, that can be determined, and the acceleration of the body can be determined. Now use this idea, let us solve one simple problem. So question number 1. You take the question number 1. Two blocks of masses 7 kilo and 5 kilo are placed in contact with each other on a smooth surface. If a force of 6 Newton is applied, so 6 Newton is applied here from the left to the right on the block 7 kilogram, then the force on the lighter mass is. So there are 4 options are given. Now in order to solve this problem, you have to first draw the free body diagram. That is important. So first draw the free body diagram for 7 kilogram. So F1 is acting as given here, which is 6 Newton, and the two blocks are in contact. So the contact force from the second block to the first block is given by small letter F, and the acceleration is along the direction of the force. So from this you can get an equation, F minus F, the differential force, is the net force, which is equal to mass times acceleration. Mass is 7, acceleration is 8, therefore this is 7. So you will get this equation. Now if we take the free body diagram for the second mass, this is 5 kilogram, and the small f is the contact force acting on the block, second block, because of the first block. So this is the small f is the contact force, and A is the acceleration. From this F is equal to 5A. So you have to get the second equation. So this is equation 2, and this is actually equation 1. So there are 2 equations, and once if you add these equations 1 and 2, you will get the force, and so this is 7A plus 5A, which is equal to so once if you add 1 and 2, you will get this equation, and from this the acceleration A can be determined. A is equal to 6 divided by the total mass, acceleration, and the force divided by the acceleration. F is equal to M1, F divided by M1 plus M2. Therefore, this can be determined, which is 0.5 meter per second square. So the acceleration can be calculated. Once if you know the acceleration, because you are asked to find the contact force, so F is equal to 5A from equation 2. So this is 5A, acceleration is 0.5 you have calculated. So from 5 into 0.5 is equal to 2.5 Newton. So the option B is a correct option. Now we consider the equation, the problem number 2. Now here we consider 3 blocks ABC. There are 3 blocks ABC of masses 4 kg, 2 kg, 1 kg respectively are in contact on a frictionless surface are shown. So the diagram is given. If a force of 14 Newton is applied on the 4 kg block, so this force 14 Newton is applied here, then the contact force will be in A and B. Now you are asked to find the contact force. So here first you have to draw the free body diagram for the first block, block A. Force F is acting. So this is along the direction. So this is given. Acceleration is this is acceleration. And the block B gives a contact force on A, which is called as the F1. So the F1 is the contact force acting on block A due to B1. Then, if we similarly, so you can write down the yes. Now we have already shown that the acceleration is equal to force divided by the total mass of the system. So F divided by the total mass m1 plus m2 plus m3. So you will get the acceleration. And from the body diagram, free body diagram, F minus F1 is equal to ma. So from this F1 is equal to F minus m1a, and you can substitute the value of the F. So from this equation, this F is equal to F is equal to m1 plus m2 plus m3 into A. So from this equation you have, so substitute the value of F here and m1 minus m1a, simplifying you will get m2 plus m3. So m2 plus m3a, that is your contact force. So what is m2 and m3? 2 plus 1, 3. So F1 is equal to the acceleration is given, that can be found out. The contact force F1 is also found because m1 m2 plus m3 times the acceleration. Acceleration is the total force divided by the total mass, which is 2. So F1 can be determined by this expression. So this is the contact force. So F1 is the contact force between A and B. So the option A is the correct option. Now let us consider a system. So this is the problem. Now here, let us discuss a system. If blocks A, B and C of mass m1, m2, m3 are kept on the free smooth surface, frictionless surface, then force is acting from right to left. So previously we have calculated the force is acting from left to right. Now here it is if you consider this is a positive axis, in this direction is a positive and this is a negative axis, then the force is acting along the negative axis. So if you consider this is a positive x and this will be minus negative x. So the force is acting along the negative x direction. Now you consider the first block A and you draw the free body diagram. So the mass is m1 and acceleration is A. A is along the direction of the force, which is, so the actually this is also moving along the negative x direction, and F1 is the contact force. So because B is in contact with A contact force is acting from B to A. So that is also given. as I have told you that the contact force is always acting towards the body. Now here, if you use Newton's second law, the force F1 is equal to M1 times A. So this is equation 1. Next, let us consider the second block B. Here, there are two forces, contact forces are acting on the block B. So because A is in contact with B, therefore the contact force acting on B from A is equal to F1. And because this F1 and this the contact force acting from B to A is the same as the contact force acting from A to B. So this is F1. Now the contact force acting from C to B is a different one. It may be different. So this is called this is F2. And the acceleration is also given as A along the negative direction, negative x-axis. So from right to left, the body is moving. Now, since it is moving from right to left, the force F2 must be larger than F1. So the net force is F2 minus F1, which is equal to the mass M2 times acceleration. So this is noted as equation 2. Now if you consider the block 3, which is a block C, the mass is M3, and M3 is in contact with the block B, therefore F2 is the contact force which is acting from B to C. So this is F2, and capital F is the force acting, external force acting on the block C. So that is F. Acceleration is A. So F. So the equation of motion is F must be larger, then only it will move from F must be larger than F2, then only it will move along the negative x direction. Therefore F minus F2 is equal to M3A. So which is equation 3. Now let us calculate the acceleration. Acceleration we have already calculated. Once you add all the three equations, you will get F is equal to this expression. So from this, acceleration is equal to the total external force divided by the total mass. So F divided by M1 plus M2 plus M3 is the acceleration. Now if we substitute the value of acceleration in equation 1, so if we substitute here, then F1 is equal to M1 times the acceleration F divided by M1 plus M2. So this is the contact force between A and B. Now if we substitute F1 in equation 2, then F2 can be calculated, and the F2 is calculated as M1 plus M2 divided by M1 plus M2 plus M3 times here. So the contact force F1 that is between block A and B, and the contact force between B and C, as well as the acceleration can be determined by using the free body diagram. Now let us consider an example, problem 3. 3 blocks A, B and C of masses 4 kg, 2 kg, 1 kg. So this is here 4, 2 and 1. 3 blocks. They are in contact in a frictional surface. A force of 14 Newton. So the force is acting from right to left. So along the negative x direction. Then the contact force between A and B. So we are asked to find the contact force between A and B. Now, so the free body diagram for the three masses are, for the first block having mass A, the contact force is F1 acting from block B to A, F1, which is given, acceleration is A. So F1 is equal to 4A is the Newton's second law. The force is equal to 4A, equals to 1. For the block B, there are two contact forces acting on the block B. One is acting from A to B. The contact force F1 is acting from A to B, and F2 is the contact force acting from the block B to C. Now the difference F2 minus F1 is 2A. So F2 minus F1 is equal to 2A. Then if you consider the block 3, there are two forces. One contact force is acting from B to C, which is F2. Another force, external force F is acting uh, this is the external force acting on the block C. So this is your block C. Therefore, F minus F2 is equal to 1A. So this is equation 3. So you have 3 equations. Adding the 3 equations, you will get the F1 gets cancelled, F2 gets cancelled. So the force, net force is equal to M1 plus M2 plus M3 times A. So F is equal to 7A. The acceleration is equal to F by 7 or 14 by 7. So this is 2 meter per second square. So from this, the acceleration is found. So the contact force F1 is equal to 4A. So you are asked to find F1 alone. So F1 is equal to 4A from equation 1. You substitute for A. A is 2 meter per second square. Therefore 4 into 2 is equal to 8 meter per second square. So the answer is the next is we are going to discuss the motion of blocks connected by massless string. There are 3 blocks we are considering: block A, block B and block C. The mass is M1 and M2 and M3. And the force F is acting, so you are connecting a string between block A and B and block B and C. So the block A and B are not in contact. They are connected by a massless string. Between block B and C, again there is a massless string. Now the force F is acting from block because we are pulling the whole system by means of external force here. So A, B, C are they are pulled along the negative direction F. So this force is acting. Now here we have to consider the free body diagram. Now you take the block A, the mass M1, and the tension in the string is acting from A to B, which is in the block A there is a tension force which is T1 is acting from A to B. If you consider block B, the tension force is acting from B to A, both are equal and opposite in direction. So same tension is produced along the same wire. Same for if you consider a single string, then the tension acting on this will be equal and opposite. So here if you consider free body diagram, this is mass is M1, F1 is the external force acting on the block A, T1 is the tension force acting from the block A to the positive direction. Now it is very important to note that if you consider a block B and for the tension force is acting away from the block. If you consider the previous case, contact, if the two bodies are in contact, the contact force is acting towards the block, but here the tension force is acting away from the block. So this is much important. Now you draw the first block diagram, first free body diagram, and for the block B, you take the you draw the free body diagram. T1 is the tension acting from B to A along the wire string, and the tension T2, because they are the different strings, so the tension may be different. So T2 is acting from B to C along the string. So you consider this free body diagram for the second block, and for the third block, the block C, the mass is M3 and the tension is acting from C to B along the string. But in all the three cases, acceleration is moving along the direction of the force. That is important. Now, let us write down the equation of motion. F minus T1 is equal to M1 into G. So this is the first equation. And if you consider the second block, T1 minus T2, because T1 must be larger, then only the block must move along the direction of the force. So T1 minus T2 must be equal to M2A. This is the second equation. Third equation is T2 is equal to M3. So this is you have three equations, and if you add all the three equations, so the T1 and T1 gets cancelled. T1 here minus T1 gets cancelled. Minus T2 and plus 2 get cancelled from the left side of the equation. So finally the left side will get a F. If you add the right side of equation 1, 2 and 3, which is M1 plus M2 plus M3 times A, therefore the acceleration is given as F divided by M1 plus M2 plus M. Now, if we substitute the value of A in equation 3 here, M3 times A acceleration if we substitute, so T3 is equal to M2A, which is equal to M3 F divided by M1 plus M2 plus M. And if we substitute this T2 in equation 2, you can find T1, and once this is equal to M2 plus M3 times A, or M2 plus M3 F divided by M1 plus M2 plus M. Now, if you consider another case, the motion of the blocks connected by a string, again here we are considering three blocks A, B and C. AB is connected by a string, and B and C are connected by a string. But here we are giving a force so that all the three blocks are moving along the plus x-axis. So it is from left to right it is moving. Previously it is moving from right to left. Now the acceleration is A. The acceleration is always along the direction of the force. Now here also you, as before, you have to draw the free body diagram. So for the first mass, M1, the acceleration, here T1 is the tension acting from A to B along this string. So I have told you that the contact force is acting towards the block, tensor force is acting away from the block. So this is T1. If we consider this is for the block A, and for the block B, you have two tensions, because one is from B to A, this is tension is T1. From B to C, because B and C are connected by a string, so from B to C the tension is given as T2, and the acceleration along the direction A is given along the direction of the force. So therefore the difference T2 minus T1, this difference is equal to M2 times A. So this is your second equation. If you consider the block C, mass M3, one is the tension acting, this is T2 from C to B. So tension force from B to C and C to B, they are the same because they are connected by the same string. Now here F is the external force acting on the block M3, which is a pulling force. Now here if we use a equation of the second of motion, Newton's second law of motion, then F minus T2. So F must be larger than T2, then only it will move along the direction of force. So F minus T2 is equal to M3. So you have three equations. So if you use first block, T1 is equal to M1A. If you use the second block, T2 minus T1 is equal to M2A, equation 2. And if you use a third block, F minus T2 is equal to M3A. Once if you add the 3, then the equation is F is equal to M1 plus M2 plus M3 times A, or A is equal to F divided by M1 plus M2 plus M3. Now if we substitute the value of A in equation 1, you will get T1 is equal to M1F divided by M1 plus M2 plus M3, and if substitute T1 in equation 2, then you get T2, and the T2 is found to be M1 plus M2 divided by M1 plus M2 plus M3 times the external force. So the tension acting on the strings as well as the acceleration can be calculated if the most of the blocks are connected by a string and it is moving along the positive x direction. Now consider a problem. Question number 4. 3 blocks of masses M1, M2, M3 are connected by a massless string on a frictionless table. They are pulled with a force T3 40 Newton. If M1, M2, M3, their masses are given 10 kg, 6 kg, 4 kg respectively, the tension T2 will be. So the diagram is given. So it is moving along the positive direction. So now you draw the M1, M2, M3, and the T1 is acting on the wire, on the string between the two blocks M1, M2, and the tension T2 is acting on this string which is connected between M2 and M3. So the tension T2, because you are asked to calculate the tension T2, the expression for T2 is available, M2 plus M1 plus M2 divided by M1 plus M2 plus M3 times here. So this expression is known from in the previous discussion we have already calculated. So we take the expression, you substitute for M1, M2, 10 plus 6, and M3 is equal to 4. So 10 plus 6 plus 4. So you can substitute all the masses times the 4. This is into the force. Force is given as 40 Newton. So this is a substitute. So here this is a tensile force. T3 is a force which is a tension, because this is pulled through another string. So this F is equal to T3, because all the 3 blocks are pulled through a string. So a tension force is acting, and that tension force is the same as the force that you are applying. So F is equal to T3, which is equal to 40 Newton. So once if you substitute and simplify, you will get 32 Newton. So the option D is the correct option. Now let us consider another problem. 3 blocks of mass 2 kg, 3 kg, 5 kg connect to each other with a light string, and they are placed on a frictionless surface as shown in the figure. So the figure is given to you. The system is pulled by a force. So this is pulled by a force. F is equal to 10 Newton. So here then the tension T1 in the string. So the tension here between this block of mass M1 and the block of mass M3. So the T1 is given in the diagram. So we are asked to find T1. So what is the acceleration? Acceleration as usual, F is equal to the total force divided by M1 plus M2 plus M3. So if you substitute F is equal to 10 divided by the total mass is equal to again 10. So the acceleration is calculated as 1 meter per second square. Then you draw the free body diagram for the first block of mass 2 kg. So this is a F1, and this is a T1 tension acting on this string, which is from the first block of mass 2 to the second block of mass M3. Now from this the equation of motion is F minus T2 by F must be larger, then only it will move along the direction of the acceleration is moving along the direction of the force. Therefore this F must be larger. So F minus T1 is equal to mass times acceleration. So here M1 times the acceleration. M1 is given as 2 kg. Therefore substitute 2 into acceleration is 1. 2 into 1. Therefore this is your first equation. Then from this T1 is equal to what? F minus this value 2. So F is 10. So 10 minus 2 is T1. So which is the T1 can be, so the tension of the string can be calculated, which is B. Answer is B. Now we discuss another type of problem. So motion of a block connected over a pulley. So we consider two blocks, block A and block B. Block A is carrying mass m1, block 2 is carrying mass m2, uh, and this is connected over a pulley. So there is a pulley here. Now since they are connected through a string, a tension T1 is acting from the block, and also if you consider a same string, the tension force acting on the string are equal, and therefore if you consider a tension from the left side, tension acting on the string in the left side of the pulley is the same as the tension acting from the right side of it. So if you consider block M2, block B of mass M2, then again the tension is T1. So if you consider a same string, the tension will be equal. So this is T1 and T1. Now if you consider a pulley, because if you consider this segment, the left side segment, T1 is acting from block A towards the pulley direction, and again T1 is the tension acting from from up to down. So T1 and T2, T1 T1. So this is given as in the diagram. Both are equal in opposite direction. So on the right side also, there are two. T1 is acting downwards from the pulley, and again T1 is the tension acting upwards from the mass M2. Both are equal magnitude. Now this pulley is connected by another string which is attached to the rigid support. So that tension may be different from T1. Therefore this tension we call as T2. Now let us draw the free body diagram for each mass. So if we consider a mass M1, here you note down the direction of acceleration. A is moving up, and T1 is also acting upwards. But here, since there is a mass M1, due to gravity, so the M1G will be the force acting on the M1 towards the downward direction. So because of the acceleration due to gravity, F1, M1 and G, so the force is equal to mass into the gravity. So the downward force is acting on the mass. So you have three forces. M1G is the force due to gravity which is acting downwards. T1 is the tension acting upwards on the block A. So therefore, since the block is moving upwards, T1 must be larger. Therefore, T1 minus Fg is equal to M1E. So you can write down the first equation. You consider another block M2, and the M2 again M2G. This is the force of the force due to gravity acting along the towards the earth, so downward direction, and T1 is the tension acting upwards, and the block M2 is moving downwards because in the diagram the acceleration is given in the downward direction. So this is the direction of the acceleration. Now using the Newton's law, because M2G must be larger than T1, then only the block will move downwards. So M2G minus T1 is equal to the mass times acceleration. So you can get the equation 2. And for the pulley also you can write you can draw the free body diagram. There are two tensions acting on the two sides of the string, and T2 is the tension acting upwards from the center of it. So this is the free body diagram for the pulley. Now you take a 1 and 2 and adding equation 1 and 2. So once if you add 1 and 2, then M2G minus M1G is equal to M1A plus M2. So if you add, the T1 gets cancels, and you will get m2g minus m1g is equal to m1a plus m2g. So from this the acceleration can be calculated. The acceleration is equal to m2 minus m1 by m1 plus m2g. So this is can be easily determined. Now if we substitute the value of a in equation a, then the t1 can be calculated. Substitute the value of a in equation 1, you can get the t1, and the t1 is equal to 2m1 m2g divided by m1 plus m. So the t1 can be calculated, and you substitute this value of t1 in equation. Alright, you have calculated acceleration t1. If you substitute the value of t1 in equation 3, then the tension t2 is equal to 2 times t1. So all the three can be determined for such a type of systems. Now let us consider another type of problem. So here there are two blocks of mass m1 and m2 which are connected by a string. On the right side, on the left side there is only one mass which is having a mass m1. So you consider this is block A, this is your block A, and mass m1. Now again, as before, you can draw the free body diagram. Free body diagram is important to solve this problem. So this is you consider a block of mass A. The mass is m1. The tension is acting upwards from towards the direction which is mentioned there, and the m1g is the due to the force due to gravity there is a downward force acting which is m1g, and the acceleration is upwards. So using this free body diagram, since the body is moving upwards, t1 minus m1g is equal to m1e. So using NEET and second law, you can arrive the equation 1. So this equation one can be arrived. You consider the another block, block B of mass m2. Here there are tension force acting along the string are t1 upwards and t2 downwards. So there are, because there are two different strings, so you have two different tensions. So t1 is the tension acting upwards and t2 is the tension acting downwards. In addition, there is a force because there is a mass m2. M2g is the due to gravity there is a force acting downwards, which we call as m2g. Therefore, the net downward force is equal to t2 plus m2g. Now, t2 plus m2g, so this must be larger than t1, then only the body will be moving downwards. So t2 plus m2g minus t1 is equal to m2a. So this is equation 2. Equation 3 is, you consider the block C, mass is m3. There is a upward tension acting from the block C, which is a t2. The acceleration is downward a, and because of the gravity there is a downward pull, this m3g is acting on the block C. So the equation of motion is m3g minus t2 is equal to m3 equation 3. So again you have three equations. Adding the three equations, then from this the acceleration can be obtained. The acceleration is given as this is m2 plus m3 minus m1 into g whole divided by m1 plus m2 plus m3. You substitute the value of the acceleration in equation 1. T1 can be calculated, and this T1 is found to be this value. So if you simplify this expression, you will find this value 2m1 into m2 plus m3 times g whole divided by m1 plus m2 plus m3. So you get the equation 5. You substitute T1 in equation 2, you can simplify and you can get the T2. This T2 is calculated as 4m1 into m2 plus m3 into g divided by m1 plus m2 plus m3. So this is equation 6. Also, if you want to calculate the tension acting in the this wire in the pulley, so this is T3 must be equal to T1 plus T2. There are both sides are T1, T2, T1 both are equal. So T3 is equal to 2 times T1 So if you substitute the value of T1 in that expression, you can calculate the tension T3. Now let us discuss some problem using this type. A light string passes over a frictionless pulley to one end of a mass uh, 6 kg is mass of 6 kg is attached to its other end. A mass of 10 kg is attached. The tension the thread will be so. Here there is a thread is connected to a pulley, and one side 10 kg and another side is 6 kg as given. So since the 10 kg mass is larger than 6 kg mass, it will be acting downwards. The force will be acting downwards. So the acceleration is towards the downward direction. So here let us draw the free body diagram for the block of mass 6 kg. 6 kg upward direction the tension is T1, and because there is always a downward pull due to gravity, which is M1G, and the acceleration on the left side of the block is upwards. So if I write down the equation of motion, T1 minus M1G is equal to M1E, and T1 because M1 is given as 6, so T1 minus 6G is equal to 6 times A, so that is the equation 1. Now if you consider the second block, the mass is 10 kg, T1 is acting upwards, and M2G due to gravity the force is acting downwards. So if you write down the equation of motion, which is M2G minus T1 is equal to 10A. So this is also given. So from this, so this is equation 2. Once if you add equation 1 and 2, you can get the acceleration, and the acceleration is found to be G by 4. And T1. So from equation 1, you can find T1 is equal to M1G plus M1A, and the M1 is available, G is known, A is G by 4. Once if you substitute, the value of T1 is calculated as 73.5 meter. So the option D is the correct one. Now let us discuss an inclined plane. One inclined plane. So this is one side is inclined, the one is a base, another one is a vertical plane. Now a block of mass M1, the block of mass M1 is connected to the block of mass M2 through a pulley, and A lies on the inclined plane, and it is hung vertically on the other side. So this is a vertically acting. Now since the tension, there is a tension acting from block A along the vertical direction, along the direction of motion. So this is T1. If we consider block B, again tension T is acting upwards from block B. Since the tension acting a single wire must be same, so both must be T. Now since the block M2 is moving downwards with an acceleration A, so the block A is moving along the inclined plane with an acceleration B. So the acceleration of the two will be, the magnitude of the acceleration is the same. Now let us write down the free body diagram. If you take the free body diagram for the mass M1, what are the forces acting? One is the tension force acting along the inclined plane, and one is a downward force due to gravity, which is M1G is acting vertically downwards. But the component of the force along the direction of the inclined plane must be calculated. So the direction of the force acting along the inclined plane, so which is perpendicular to the other direction. So if you have two faces, one face is acting the tension T, the other face the force acting on this block will be M1G sin theta. because theta is the angle of inclination, then the force acting along the direction of the inclined plane will be m1g sin theta. So using this free body diagram, since it is moving upwards, so t must be larger than m1g sin theta. So the difference t minus m1g sin theta is equal to m1 times. So this is equation 1. So from this m2, yes, so this is equation 1. Now you consider the second block, m2, your tensile force is acting upwards, and the downward due to gravity, m2g, the force is acting downwards. Since it is moving towards the vertical direction downwards, so m2g must be larger, so m2g minus t, so this difference is equal to m2g. So this is equation 2. Once if you add equation 1 and 2, you can get the acceleration. This expression for the acceleration is found to be m2 minus m1g into g divided by m1 plus m. And if you substitute the value of a in equation 1, then the tension can be calculated. So this is a expression of tension m1 plus m1 m2 into 1 plus sin theta into g, this is g divided by m1 plus m. Now we discuss another type of problem. So now let us do one problem using the for the above inclined plane. Two blocks of mass m and 2m. So here the block of mass A and Pm are connected by light string passing over a frictionless pulley as shown in the figure. The mass m is placed on the smooth inclined plane of inclination theta. So 30 degrees. 30 degrees is the angle of inclination, and 2b hangs vertically. So the other side 2m. So this mass is 2m, which is hangs vertically. One is moving along the direction of the inclined plane. If the system is released, the block moves with an acceleration equal to. So we are asked to find the acceleration. So acceleration must be the same for both the blocks. Now here we have already calculated the expression for acceleration. So m2 minus m1 sin theta g divided by m1 plus m. So you know the value of m2 is equal to m, and m1 is equal to m, and theta is equal to angle of inclination is given sin 30. So if you substitute this value, you have calculated the acceleration is found to be g by 2. So the option C is the correct. Now another type of problem is, instead of one inclined plane, we consider two inclined planes. So here the block of mass m1 is in inclined plane, is in an inclined plane. Here the angle of inclination is alpha, and block of mass m2 is placed on the other inclined plane, whose angle of inclination is beta. So there are this alpha beta may be different. Now there are two masses m1 and m2, which is passing, and this is connected by a string over a pulley. So it is connected by a string over a pulley, and we assume that the mass m2, since the angle of inclination beta is larger than alpha, we expect the mass m2 is moving downwards on the other side of the pulley. So this is the direction of acceleration. The tension acting on the string from A is T. The tension acting on the other side of the string from the block M2 is also T. Since the string, there is the same string is connected with the two masses, the tension must be the same. Now let us draw the free body diagram for this problem. You consider the block, first block. This block is having mass m1. This is kept on the inclined plane with an angle of inclination alpha. Therefore, the two forces are acting. One is a tension acting along the inclined plane, along the direction of, and the direction of acceleration is also given here. And because of the gravity, there is a m1g would be the force acting vertically downwards, which is the force due to gravity acting on the mg. Let us calculate the component of the force along the plane. The component of the force along the plane is calculated as m1g sin alpha. So from this, since it is moving up, t must be larger, so t minus m1g sin alpha is equal to m1 alpha is the first equation. And the free body diagram for the second equation is here the angle of inclination is different, mass is different. So there is a tension force is acting from the block towards the pulley, which is given. Since it is moving, sliding down along the second plane, inclined plane, and M2G is the force due to gravity acting on the block M2, and the component of the force acting along the direction of the inclined plane is M2G sin beta. So the net force M2G sin beta minus T, which is equal to MT. So this is the equation of motion for the second block, mass M2. Now adding the two expression gives the acceleration. A is equal to M2 sin beta minus M1 sin alpha into G divided by M1 plus. So this is the acceleration. And once if you substitute the value of A in equation 1, you get the tension, and so you substitute and you can simplify. You can find that T tension is equal to M1 M2 into sin alpha plus sin beta into G divided by M1 plus. So for one side is inclined, you can calculate the acceleration of the tension, and if both sides are inclined, then also you can calculate the acceleration of the body and the tension acting on the spring. Now let us take a problem. The acceleration of the system of two bodies over a bed as shown in the figure is, so this is a two inclined plane. One side the angle is given as 37 degree angle of inclination, and the other angle of inclination is 53, which is given. But here the mass is the same mass. Now here, as before, the component of the force are acting on the left side of the mass along the direction of the plane is mg sin 37. So mg sin 37, and T is the tensor force acting, of course. So the difference is the force acting along the plane, the left side of the plane, which is equal to mass times the acceleration. Now if you take the other side of the plane, this is the component of the force is mg sin 53, and mg sin 53 must be larger than T. So mg sin 53 T is equal to capital M times A. Adding these two, you will get the acceleration. The acceleration is g by 2 into sin 53 minus sin 37. So this is the expression for the acceleration. Now this can be solved by using a trigonometry. Sin A minus sin B is equal to 2 cos A plus B by 2 into sin A minus B by 2. Sin 53 minus sin 37 is equal to 2 cos 45 into sin 80 degree, because you add A plus B by 2, you get 45, and if you find A minus B divided by 2, you will get 8. So sin cos 45 is 1 by root 2, sin 80 degree is equal to 0.139. Once you substitute, you can calculate the value of the acceleration is almost 1. So using Newton's second law, you can discuss or solve problems related to if two masses are, if masses are in contact with each other, and if you are giving a force, and whether it's from right to left or left to right, you can calculate the acceleration of the body as well as the contact force. Second case is we have discussed that all the three blocks are connected by means of a string, and if a string is pulled leftwards or rightwards also, you can calculate the tension acting on the string as well as the acceleration of the body. And the third, we have discussed a pulley So the two balls are connected through a pulley, or more than two balls can also be connected through over a pulley, and if they are connected by a string or a pulley, then also you can calculate the tension acting on the string and the acceleration acceleration of the body. And another case we have discussed the inclined plane. One side is inclined as well as both sides are inclined. In that case also, the acceleration of the body as well as the tension acting and the strength that can be calculated.